Darkness, humidity, more darkness. You have been wandering in these caves for days now, searching for the legendary hammer of Lambda, and you found nothing so far. You enter a large room of typical dwarven architecture. In the distance, beyond rows and rows of pillars, a bonfire flickers, illuminating a tall archway and the silhouette of a creature that appears to be standing guard. What do? So you could do many things. You could take your arrow, your bow and your arrow, and you could shoot the creature. You could maybe go away and do nothing. You could try to come closer, talk to it. You could try to be stealthy. There are many, many, many things you could do. So the reason I did this little snippet, or this little segment, is because it illustrates some of the core ingredients of role-playing games. Like if you were reading a book, like if you are reading The Hobbit, The Lord of the Rings, you would have this situation, somebody would describe it, you have a great story, and then the hero does something. And maybe this is what you want to see, maybe this is not what you want to see. You cannot do anything about it. So the essence of role-playing game, or RPGs, is two things. One, you're trying to tell an epic story with heroes, with adventures, all of that. And the second part, which makes it different from a book or from a movie, is like you let the user or you let the adventurers decide what happens in the book. This is what role-playing games are about. So now, at that point, you might also ask yourself a question, and the question is like, why would that person be talking about Dungeons and Dragons at a developer conference? NDC, in NDC, the D is not standing for Dungeons and Dragons, it's standing for like a developer. So why? What is this happening? And for that matter, you might also wonder who that person is. So first, I should start with introducing myself, or like telling you my origin story. So my name is Mathias Brandewinder. You can find me on Twitter as at Brandewinder, or like I have a blog as well. And I look that way on Twitter, on GitHub, and all these places, like exactly like me. And the reason I wanted to talk about the origin story was, so Dungeons and Dragons, so normally people know me primarily for two things. One of them is like F# and functional programming, and the other one is machine learning. So Dungeons and Dragons doesn't quite fit. So what happened to me last year was I got into a bit of a burnout phase, like I was just tired of coding and not very excited. And another thing which happened was when I was a teenager, I was really excited about Dungeons and Dragons. I got all the rules. I knew everything on the back of my hands. And then it's like I never got to play a game. I couldn't find people to do it. And so this was one of my long frustrations, like maybe I will just never play D&D. And last year, a friend of mine told me, hey, we should play D&D. And so since then, for the last year, I have been doing two things. I have been the Dungeon Master in a campaign for a year, which has been awesome and which also got me back into programming. And so how did that happen? Well, it's like if you're a dungeon master, you kind of need to know all the rules. And so two things is like one, I thought, okay, if I want to know the rules, a good way to do this would be to write the rules in code. So I started this project and think I'm going to spend a couple of weeks and just like write the code so that I know the rules. You can probably imagine that my idea was like 3 weeks, 4 weeks, so it's been 4 months. And the thing is like growing and growing, so but this is fun. And the other reason is because I'm a software engineer, is that I thought, of course, I need tools and I need code. So it's like I started to write my own tools so that I can be a better DM. And so what I wanted to do here was to show you a bit like what I've been up to over the past 4 months, trying to essentially implement the Dungeons and Dragons rule in F#, showing you a bit of maybe a couple of tricks on modeling things using F#, and show you a bit the state of my project. And that's what I have, so let's do that. So our campaign is going to be a short campaign of 1 hour. I figure I should probably talk a bit about what is D&D. So I realized when I started this project that it turns out that developers and D&D players have a very, very big intersection. So I assume that a lot of you are familiar with it, but just in case, I'm going to talk a bit about it. Then I'm going to talk about modeling monsters with F#. So modeling monsters will be mostly about really domain modeling with F#. Then I'm going to go into a piece which I think is particularly interesting and has nice patterns, which is modeling dice with F#. So, and finally, I'm going to show you, which will be a kind of a nice build-up on like last talk by Jim. Like I will be showing you something called Fable Elmish, which is like building like an application or UI using the Fable Elmish patterns to run combat. So let's dive into the campaign. And let's start to talk about Dungeons and Dragons and the rules of Dungeons and Dragons. So a game, or a game like a role-playing game, is about agency. So it is about like giving somebody the capacity to do something in a given environment. So that's what a game is about. And one question would be like, what is it that makes a game interesting? So you need two things. In general, like you need to make decisions. Like if you have nothing to decide in a game, the game is not particularly interesting. If it's just mechanical, if it doesn't matter what you do, if no matter what you do, you win, or if no matter what you do, you lose, that's not going to be a very fun game. So you should have like decisions, and the decisions should have consequences. And the thing which, the other thing is like the consequences should not be entirely random. If you tell me, I move into the room and I tell you, you die, this will not be a very interesting game. What's interesting is a place where you kind of understand the environment, and you kind of know that if you do things, some things could happen, some things, you want to be in a place where if you have a good result, you know it's because you have been smart. So this is the reason why you need rules. Like if you didn't have rules, you would have like a nice storytelling, and this would be fun, but this would not be a game. So you need rules for this to work. Every role-playing game has rules. Dungeons & Dragons is probably the granddaddy of every role-playing game. I believe it's the first. I was kind of shocked to see that the first edition came out in 1974. It's almost 50 years old. Has been going through many iterations. Like the current rule set is like a 5th edition. Has been like, I think, 11 published iterations. It's the first role-playing game, and it's, the universe is like Tolkien-inspired, like loosely Lord of the Rings. The rules, the core rules are what is called the player's handbook, the PHB. The PHB, so just the basic rules is like 316 pages. That's a pretty solid piece of documentation. There is a shorter version online, like if you don't want to pay for it, there is a 180 pages free basic rule. So the minimum rule set is like 180 pages. That's really the minimum. Like if you want to really play for an extended time, you're probably going to need 3 books. One of them is the PHB, 300 pages, the DMG, the Dungeon Master Guide, and a Monster Manual. So together, that's about like 1,000 pages of documentation. So this is probably why I'm still like 4 months in trying to code the rules, because there is a lot of rules. And this is also why I wanted to code them, to make sure I understand what's going on, because there is a lot of things in there. So when you play D&D, what happens? There are 2 roles, or 2 things. Like I described the fact that you have agency, so as a player, you can operate in a universe. So to do this, it's like somebody needs to be the universe. So you have 2 roles. One of them is players. So the players are like people who are trying to have a fun adventure together, and they decide what they want to do. And then it's like the DM, or the Dungeon Master, is going to be essentially God or the world around them. He's the person who's going to decide how the story goes, what happens, if you succeed, if you die, all these things. So the DM is the universe. In the game, there are also 2 slightly different phases. So that's less clear-cut, but I would say like one mode is like you're in a role-playing game. And when you're role-playing, the rules are maybe less important. It's more flexible. It's more about interacting with people, having discussions, developing your character. And the second part is combat. So a lot of it, I mean, in Tolkien, is like you have battles all the time, and so in D&D, you have a lot of combat, and so the moment you go into combat, the rules become very rigid. Like you have turns last 6 seconds, you have a specific order, there are things you can do, cannot do. It becomes very much like a war game. So if you want to code the rules, the role-play part is like there is really not that much I can do about it. Like it's mostly about storytelling. Trying to build a program which is going to build a story and build dialogue between people is interesting, but it's a crazy project. So I cannot really do that. So what I focused mainly on was modeling combat, because that's much more realistic. So this is what I'm going to be talking about. And my project right now is essentially modeling combat in D&D. So let's start now, and let's start to look at domain modeling with F# and trying to model things in D&D. So one first thing we could look at is like, as I said, is like you have adventures, you have creatures who are like acting in the world. And so if you want to have rules which reflect which give you a sense for like what may be successful, not successful, you need to have a bit of a model for creatures. So for instance, if I give you the creature on the left, that's a goblin, that's a small creature which looks like pretty agile. The thing on the right looks like it's an ogre, it's like pretty brutal and pretty strong. Obviously, like if you told me I'm going to attack this creature, it's like different things should be happening. So we need to be able to model that. How is this done? This is done by using what's called the stats block, or like the statistics. So you have for every monster and creatures something like a character sheet which describes like what you should know about that creature to make it realistic and to play with. And for the particular thing we care about, a creature is going to have abilities. So the player handbook, page 173, says 6 abilities provide a quick description of every creature's physical and mental characteristics: strength, dexterity, constitution, intelligence, wisdom, and charisma. So what this is saying is like I have like 6 things. These 6 things are the abilities which can describe a creature. How would I model this in F#? Well, the way I would model this is I would model this using what's called the discriminated union. And so I would say, like, I have a type. When I talk about an ability, I can talk about one of these 6 things. It cannot be anything else. It has to be one of these things. So an ability can be either strength or dex or con or int or whiz or char. So this is a discriminated union. Now, the PHB again, page 173, abilities. Each of a creature's ability has a score, a number that defines the magnitude of that ability. So this is how now you put it together and say, like, when I have a goblin, this is how strong or smart they are. To do this, so this is a bit of a different situation from before. Before I said an ability can be this or this or this. What I'm saying now with abilities, I'm saying a goblin, an ogre, anybody needs to have like one value for these 6 things. To do this, we're going to use a second type. So the type is called a record. And here I'm going to say something like this. The scores, which will describe a goblin or an ogre or whatever, is going to be, I'm going to have 1 strength, 1 dex, 1 con, 1 int, 1 wisdom, and 1 charisma. So this is now describing fully a creature. How do you use the types I described? So if I describe the score, I might want to ask something like, what is the dexterity for my goblin? This is to do this, we're going to use something called pattern matching. So here I'm going to say, I want the score for a particular ability. So this could be dex, this could be strength, whatever. And I have scores which are the scores for maybe the goblin. And here what I'm going to say is like, take the ability and match on the shape of that thing. So I know that an ability can be only one of 6 things. So the only thing I need to do is I need to say, fine, ability can be strength. If it's strength, do this. Give me back scores.strength. If it's dex, give me this. If it's con, give me this. Go on, go on, go on. So you have to match on the 6 cases. If any of them is missing, it's like the compiler is going to tell you you are missing something and you should deal with it. And so this is how you work with records and with discriminated unions. So for instance, now I can do something like this. I can create a goblin simply like this. Creating like the strength, the dex, and so on and so forth. And I can say, fine, I want the score for the dexterity for the goblin. I would simply do a function call and say, like, yeah, that's, I think, probably readable. Or another thing I could do is like use an operator, which is quite common in F#. That's the pipe forward operator. And what this allows me to do is to say, similar to the Unix pipe, is like whatever is on the left, push it at the end of the function. So I can say, take the goblin and push it to the score index. So take this, which will translate to score of dex of goblin. So that's the pipe operator. So good so far. Last piece, still from the PHB, I forgot the page. Each ability also has a modifier. To determine the modifier, subtract 10 from the ability score and divide the total by 2 rounded down. So great. This is a function in F#, so I don't really have much to say about it, like, except that it's completely straightforward. Like I wrote the function the way it's in the rules, and this works. So this is fine. And now I can do that. So this is what I described here. I really focused on 2 things. I focused on discriminated unions, and I focused on records. This is like one way it's called. It has a more general name, which sounds much more fancy. So if you want to sound smart, it's like you would say, I'm going to use algebraic data types. So this is what we did. Algebraic data types, if you go to Wikipedia, the statement is it's a kind of composite type formed by combining other types. So you really have like 2 types. 2 big types in functional programming. One of them is like sum types. So this was the discriminated union. And a sum type corresponds to the or statement. Like an ability can be this, or this, or this, or this. So this is what you're trying to describe with the discriminated union. The second type, besides sum types, is the product type. And product type is defining something like an and relationship. So a record would be one example. Like I described the abilities of a creature as dexterity and strength and intelligence and all these things. Another example of product types is tuples, which are also the same way. Essentially, a record is a tuple with labels. They're the same thing, just one of them is labeled and the other one is like looser. So now you know pretty much everything you need to know to model things with F#. So this is great. So it's time for you all to level up. You made it to level 2. Congratulations. So let's keep going on this adventure, and let's see how we can use this and revisit a bit the stats block for the goblin. So as a developer, one thing which was important to me historically was the idea of a ubiquitous language. So in general, I think you should be striving for describing the language you use in your code should be as close as possible to the language the user or the domain experts are using. So this is what I'm looking for. And so one good way to do that is like in this case, we have a stat block, which is like a document which people use actually to describe Dungeons and Dragons. So it probably gives you like hints as to how people are talking about things. Like in general, I recommend like taking documents of like artifacts in the domain that will help you maybe figure out how people talk about things. So if I do this, like looking at sections, titles, lists, names, what's the same, what's different, will provide you a good hints as to how to approach the modeling. So the piece I'm going to look at is like if I want to focus on combat, essentially we dealt with this section here, so this is good. Now we want to look at this section here, which is going to be actions at the bottom. So what do I see in this section? So the first thing I see is that the language is quite messy. And which is not uncommon, is like usually specification of the way people describe problems is a bit messy. But here, the section is called actions. But really what I'm seeing is that I'm seeing a scimitar or a short bow. These are not actions, these are things, and these are weapons. The second thing is that we're really talking about attacks, and a weapon, again, is not an attack. So here I can see already that I'm probably going to have some domain modeling issues down the road because it looks like different concepts are mixed and matched. But let's forget that for a minute, and let's see how we could model this. So let's look at the goblin, and the two goblin attacks I have on my stat block. So first thing is I have a scimitar, which is a melee weapon attack, +4 to hit, reach 5 feet, blah, blah, blah. Short bow, blah, 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 blah. So if I look at this, it's like the two things look there are obvious similarities, and there are obvious differences. So let's see if we can use this for modeling. Whenever I see things which have a common or similar structure, like it's probably a very good hint that what you're looking for is a record. So in this case, is like I have scimitar versus short bow, melee weapon attack, blah, 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 blah. So this, you can see already that this would be like good properties in a record. Good properties in a record, like these things have the same structure, and they're all these things together. So we probably want to model an attack as a record. So let's go for this. If I go a bit further, or if I start to dive into the internal structure, I can see that while I have things which are the same, I have also things which are different. Like it looks like here, when I have an attack can be ranged or melee. So this is like a hint that probably if I have an or statement, this is probably a good candidate for a discriminated union. I have like here slashing and I have piercing. These are also good candidates for something where I might want to use a discriminated union. I see also another case where like the reach of the weapon, both of them have reach. One of them is just 5 feet. The other one has like two numbers, 80 feet and 322 feet, 20 feet. So here again, I have something which is a reach can either have like one number or two numbers. So all the highlighted things here are probably good candidates for a discriminated union. So let's see how we do that. Let's start with the first one, which was like melee and ranged. So again, going to the documentations, if I see melee and ranged, every weapon is classified as either a melee or a ranged weapon. A melee weapon is used to attack a target within 5 feet, and a ranged weapon is used to attack a target at a distance. Okay? So that's like one or the other. So here it's like not really or, it's whereas, but like you can see how this would be an or statement. And if you go back to the manual, a weapon that can be used to make a ranged attack has a range in parentheses. The range lists two numbers. The first is the normal range, and the second one is the long range. Cool. So let's try to model this. So what I'm saying here is like at that point, I have maybe a draft or a sketch for my record, which would be something like this. Description is a string. I see that I have different types of weapons. So the type might be something like either melee or ranged. I have a hit bonus, targets, all this thing. And I have a reach, which can either be like 5 feet or 80 or 320 feet. So how do I do this? Well, what I showed you so far was that a discriminated union can have like can have labels, but what you can do as well is you can attach data to each of the branches of the label. So this is nice because this gives me a way to represent in a unified way things which can have completely different shapes. So in this case, I really have different shapes. And the way I can model them is by saying, fine, weapons can have a reach, and a reach can be one of two things. It can either be a melee reach, and if it's a melee reach, I'm going to have really 5 feet. And if it's not melee, it's ranged. And if it's ranged, I'm going to have two numbers, the short distance and the long distance. So now this is cool because I can have like two different things which are the same thing, or like one thing which can take two completely different shapes. And now I can say like my attack will have a reach. How do I use this? So again, I can use pattern matching to work with this. So again, like the reach has either melee or range with different data. If I wanted, for instance, to ask what is the range or what is the maximum range for that attack, I would simply pattern match on the reach for the attack. And then again, I will see that reach can be one of two things only. If it's melee, it's going to contain one number, which is the reach. So I'm going to give you back the reach. And if it's ranged, I'm not going to have one, but two numbers, short and long. And I'm going to give you back the long one. So that way, like, I can create things with different shapes, and I can extract back out data from the different shapes where I need it. So you might say, like, at that point, like, ranged of int times int is like not very expressive, and I would say you're right. So we can probably do something nicer. We're not animals. So one thing you would probably do here is like we can keep composing and nesting types, and instead of having like just two ints, I could create a type like a ranged reach, where I'm going to say a ranged reach has a short and a long range. And now I can nest a record inside my discriminated union. And now we'll have like a record which contains a discriminated union, which contains a record. And now this is much cleaner, because when I ask for the maximum reach, I can say ranged reach. And here I'm going to have reach.long, which is much nicer than the isolated number. So this is taking shape. I can also use like small tips, like you have a thing called a module, and you can use a module to, as a namespace, essentially. And so here I can say, like, in the module range, I will have my definition of reach. And now a range reach is going to be a range of range reach, like kind of cleaner, like I don't have to have this long name. It's nicer. So this is progress. But we have, so the good thing is like right now, with the structure I described, I should be able to describe both the attacks for the goblin. The issue, so this is great, I can do what I want. The problem is that I can also do things I don't want. Like here, with the structure I have so far, I could create a weapon which is of type melee and which has a reach of range short and long. If I look at this, like this makes no sense. A weapon cannot be a melee weapon and a ranged weapon. So it's like I created a way to create the things I want, but also things which are like not states I would ever want to see. So you might have heard this mantra from F# people and functional people in general. Is like one of the goals, I think, in good design is like try to make impossible states unrepresentable. The idea being the following is like if the best way to not have bugs is to make it impossible to even write code which would have bugs. So I can try to, I can have like weapons which are in bad states and then deal with it, or I can just make it impossible to write a weapon which is not correct. Usually, you will detect that you have that type of problem in your model if pattern matches have exceptions, or in general, if you see that you're raising exceptions in your code. If you see this, usually it's a strong hint that you're missing a discriminated union somewhere. It's a general statement on this. And so the way you would solve this is like, sure, like the problem is actually not very difficult to solve. It's like the problem was that I had really two places where I was defining the same thing. I had a type which was ranged and a reach which was ranged. I actually don't need the thing because now the reach is either ranged or melee. So if it's either ranged or melee, it's like I have all the information here. The other field is redundant. I can remove it. And now it's impossible to create a bad case. So now I'm in a place where my weapons are in a good state all the time. Couple of things. So what I've shown you so far is like where things are great and like everything works fine. And like in general, like F# is pretty good at domain modeling. Like my initial steps went very, very fast. But it also took me 4 months to partially implement the rules. So it probably means like not everything was easy. So some of the one of the things which was interesting is that the domain is very well documented, and so my assumption was that if it's well documented, like I should be able to implement very quickly. And like what I found out is like the specification of Dungeons and Dragons, like the rule set, is full of so either lies or like half-truth. I'm going to show you maybe quickly a couple of the things that I saw so that you can maybe watch out for them. So first one is like what I did was I relooked at documents and I looked at this, and so this looks like it's similar. So I'm going to use this as a pattern for my implementation. The problem is like then I started to look at other monsters, and I came across like the wyvern, for instance. So if you're not familiar with wyverns, like they are, say, a weaker dragon. And if you look at the Wyvern also has attacks, but one of the attacks is the Stinger attack, and now you see a couple of things which are interesting. So first, like, it's much, much bigger than what I had for the Goblin. So it's like, what I have so far is like, it's not going to fit in this thing. One way it's different is like, here I see it's a melee weapon attack, and yet it's like the reach is 10 feet. If you remember, like, I quoted the player handbook before, and I said like any melee attack is for 5 feet. So what is happening here? So what's happening here is like, my advice is like whenever you're talking with customers, users, is like nothing is true, things are usually true. So like what this is saying here is like in general, like a melee weapon is going to be 5 feet, but it could be really anything. So don't assume, like there is a mathematical definition of true and there is a discussion or specification, there is a customer definition of true, and so don't assume too much. The second one is like looking at the Goblin case is I looked at fine is like it has one type of damage. If I look here, is like I have actually not one damage but two damages. It can do piercing damage and it can do poison damage. So one question you might want to ask yourself when you're modeling things is like, do I have one damage or do I have at least one? And so it's not very difficult to solve. Like if you wanted to solve this, like usually instead of having a damage, you just have to create a list of damage and you're fine. So it's not very difficult to refactor. A problem which is a bit more painful is this one. It's like now I have two damages. The first one is like pretty straightforward, like the same thing as the Goblin with the scimitar, but this one is like it's the damage requires a Constitution saving throw. It can fail. It has like lots of conditions. This one I have never seen until I see this one. So in this case, what I have is like maybe one in the sense of by default, I don't have all of this stuff, but it's possible that I have very complicated conditions around the damage. So in that case, the thing you're probably going to use is what's called an option. So here I have a damage, which is like the role, the type, and I will have something which is like, say, special stuff. And I'm saying like in some case, optionally, you will also have things like save for Constitution and all that thing. This one is a bit harder to track because you know, you don't know what you don't know. So until you've seen that some saves are very complicated, you will not even know that it could be a problem. So it's a bit harder to watch out for. Another thing to think about is the following. So a manual says, like, if you look at the manual, you will see that some weapons are heavy. A heavy weapon essentially is heavy, so I'm not going to elaborate. And you have light weapons, which are light and easy to handle. So if you look at this, you would think, fine, this is very easy. This sounds like a perfect case for a discriminated union. I need a light or heavy weapon. And then it's like I can put the weight in the weapon. This is awesome until you look at the rules and you realize that some weapons are not light, are not heavy. And so now this is not going to work out with your discriminated union, right? So one thing when you use a discriminated union is like the discriminated union should be technically what you call mutually exclusive and collectively exhaustive. So it's like any time a weapon should be one of the cases and one and only one of the cases. In other words, it should describe the truth, all the truth, and nothing but the truth. Yeah, you always have to be in one of the cases. And so in this case, you could do really two things. Both of them are kind of fine. They just have like upsides and downsides. One of them is you could say, fine, either it's none or some, like that's the case I had before. So either I have no weight, or it can be, or I have some weight which can be light or heavy, or I can create a fake case medium and say light, medium, and heavy. I would say this one is more correct in that like medium doesn't really exist in the vocabulary, so I'm creating something. But light, medium, and heavy on the flat level is kind of easier to use because I don't need to go, I don't need to navigate down the tree. So upsides and downsides, it depends on how much you care about being maybe true to the model versus like versus make it convenient to work with your code. Both of them are okay, just upsides and downsides. The last one to consider also when you use a discriminated union is that one thing you want to keep in mind is that a discriminated union is closed by definition. This is the beauty of it, is that it has to be one of these things and it can be nothing else. What this means too is that it means that this is not extensible. For instance, like you could think about this. Should I make the list of weapons of the manual a discriminated union? So I could say a weapon can be a sword or a bow or this or this. This is not great because if you do this and somebody comes up with a weapon which was not in your list, there is no way to fit that in. So one question you want to ask yourself is like, is it really closed? Like, is there a chance that over time I will want to add cases to this, so that people might want to create custom cases? So that's not what a DU is for. So quick recap here. The first thing is like one thing which struck me when I moved from C# to F# was like the things were done a bit differently. But one thing I like here is like the way you compose models or you compose your domain is completely straightforward. Essentially, like you have one question to ask: is the thing a record or is the thing a discriminated union? So one or the other, and then it's like you keep going like that. And the thing is like also it's really I recall from my OO days like this idea of you should be using composition over inheritance. This is exactly what we're doing here. We're creating small things and we're composing things together. We're never using inheritance anyway. And the other thing, so is like when you model, think about is it one or at least one or maybe one? Is it really closed, and do I have all the cases? Cool. So now I want to move to dice rolls. So one piece we have not modeled so far, like on our attacks, we have like the description, blah, blah, blah. One piece we missed was the damage. And if you look at the rules, the damage is described as like 1d6 plus 2. How can we represent this in the language? So in general, like dice are pretty prevalent in Dungeons and Dragons. Like this is how you resolve pretty much everything. You have a whole vocabulary around it, like a D4, D6, D8, D10. You have a notation which represents a die with 4 sides, 6 dice, 6 sides, 8, and so on and so forth. And you can build like a whole expressions like I want to roll 5 times D10 plus 15 plus 2 times D4. So this is kind of what we're after. The question is like how do we do that? Yeah, so we want something like this. We're not going to quite get to that point, but we're going to try to get as close as we can to that. And to do that is like, so in my journeys or in my adventures, is like I met like a half-elf wizard named Thomas, and if you don't follow him, like I recommend following him, like he's pretty smart, and if you look at his talks, most of them end up involving like an expression with an evaluation, and you build expressions. So I thought maybe this is something I can do here. And this sounds reasonable because if I look at this here, what I have is I really have an expression. So what I want is I want to be able to define dice roll as something arbitrarily complicated. Like I might want to have like all sorts of dice, just one die. And if you look at rolls, they involve a couple of things. One is like they involve like dice rolls. So I can have something like roll 4 times 10-sided dice. So that's this part here. I can have like numbers, like your roll is going to be 4. Or the other thing you can do is I can take these 2 things and I can add them together. So this defines like an expression, and the question is like, can we make that happen? So I'm going to try to make that happen. Let's go here. Is it big enough, or should I bump a bit the font? Better? Yeah, this should be sufficient. So fine, so let's go, and like first thing I want to do is like I want probably a representation for the dice. So what I'm going to do here is I'm going to define a type, which is going to be a dice. And the dice is going to be simply represented as a discriminated union. And so I'm going to say simply it's going to be a D of int. So that's a bit of an odd case maybe, but like what this is doing is like it's declaring like a single case discriminated union. So now what I can do is I can say something like this, like let D6 equals D6. This is used like as a constructor, and if I run this, like what I'm getting is like I'm getting a value which is a dice, which is a D6. So pretty straightforward, so I'm happy here. And now that I have this, is like what I want is like I want to represent dice rolls. So let's create a type for this. Type dice roll. And so a dice roll can be one of multiple things. So the first thing it could be is like it could be maybe a roll. Let's start with the base elements. And so what could be, what do you have in a roll? It's like the type of thing I had was like something like 6d4. So if I want to do that, it's like let's do a roll. And the roll is going to contain 2 things. It's going to contain an integer, which is like how many times I'm running this thing. And the second thing is going to be dice. So let's try to run this. And now it, what am I missing here?
The syntax should be...
Yes, thank you. I do use this language from time to time. And yes, this is the issue here. So here we go. And now I have a dice roll. Here we go. And so now what I should be able to do is I should be able to like let roll, and I should be able to roll of like 4d6, which works. So not too bad. So progress. So I can model like one side of it, which is like what to do when I have like a roll. The second thing I want to model is like what about the cases where I have like 2d6 plus 4? So the second element I have is number. So I'm going to call this like a value. And so now I should be able to do the following. I should be able to do let roll 2, and this should be now a value of like, let's say 10. I'm going to call this roll 1, just to be consistent. And so now what I'm going to have is like, I'm going to have like roll 1 and roll 2 are both dice rolls. One of them is a roll, and the other one is a value. Progress. The third thing we need is like we need to be able to compose more complicated expressions by adding all these things together. Let's do that. So what I need to do here is like it's simple. I'm going to say if I need to add, I'm going to create a case which is going to be add. And what I'm going to add is I'm going to add, for instance, a list of dice roll. So this is kind of interesting because here what I'm creating is I'm creating a recursive data structure. I'm saying a dice roll can be either a roll, a value, or it can be the addition of more dice rolls. So I could also create like nested rolls in rolls in rolls. And for instance, so now what I should be able to do is I should be able to do the following. For instance, I should be able to do let roll 3 is add of roll 1 and roll 2. And this should work out. And I didn't run this. So now is like I can compose like the addition of all the things. And I can go like arbitrarily crazy. I can do add this, and I can nest it. So I could do something like add now roll 2, and let's say roll 1 again. So I can create like, essentially I can create like any dice roll I can think of. I can write it. I can write arbitrary complex expressions. So this is progress. That being said, is like, the good thing is that we can now represent dice rolls, and we could start to use this in damage in all the places in our code to represent like exactly what we want. That being said, is like you might tell me, like, look, like this is nice, but what we wanted was like 2d6 plus 4. What we got instead was this horrendous thing, which is like with a complicated syntax. Can we make this better? And so the answer is yes. Like I would not ask the question if I couldn't do better. So we're going to do a bit better. And so this is where we're going to use a bit of trickery. So the first thing, the first thing, and this is actually something I learned by doing this. I didn't realize every time I saw examples of distributed unions, they were just like flat unions, and I never realized that you could add methods, properties, and all these things to a distributed union. So this is what I'm going to do right here. So what I really want now is I would want to be able to do something like this, like let roll 4 equal roll 1 plus roll 2. So this doesn't work, right? Because like, it doesn't know how to add these things. How do I make it work? By adding static method. This is roll 1, roll 2. And here, all I need to do, like what am I doing wrong? I think I don't need it, but like, let me check. I have a cheat sheet right there, so I'm going to check. Static member, not method. Static member, roll 1 and roll 2, and here like all I need to do is like when I have the operator plus, is what I can do now is I could say something like this is simple. All I need to do is like I need to do add roll 1 and roll 2. And so now, like if I do this, I'm going to see it already like here. Suddenly, my compiler is happy and is telling me, yes, absolutely, I can add rolls together. So this is progress. This is much nicer. And I can keep using the same trick. Like another thing I would like is like I would want to write something like let roll 5 equal roll 1 plus 4. Or plus 45, whatever. Like instead of having a value of 1, I would like to be able to simply say like add an integer. Guess how we're going to do that? We're simply going to also add a static member here, and we're going to say take this, but now I'm going to I'm going to say like what I'm redescribing here is like the first thing in my operation is a roll, and the second one is an int. So x is an int, and here what I'm going to say is I'm going to say roll, add roll 1 and add value of x. And if I do that, it's like a miracle. Now this works. So it's like I'm getting much, much closer to what I want. Like I'm getting like a nice expression which is reflecting what I want. I can immediately do also the flip side of this, which is I want also to be able to write. I want to be able to write something like 4 6 equals 4 plus roll 1. So this is not going to work yet. And the way we do that is by using operators. Again, like infix operators. So let's do that. And here I'm going to do x is an int and roll 1. And now is like this should, I'm going to do value of x. Actually, that doesn't matter because the order doesn't matter here. But and now this should also work. So now we're in a good place, right? It's like we went from, so now what we should be able to do is something like roll 4d6 plus 7. And if I run this, like I'm expecting that this will work out. And I would say at that point, like we're getting pretty close to what we have in the rules. Like we can start to write really the dice rolls exactly the way they are in the language. I can do a bit better, so I'm going for the maybe for the sake of time, what I'm going to do is I'm going to show you like the full solved example. So the next step I would want to do is I would want to be able to also write something like this. So 10 plus 2 times d10 plus 5 plus 4 times d8. And the way I would do this is like by adding another operator here, which is going to be the multiplier operator, so that I can say now 4 times d6. And now I can do 4 times d6 plus 1. And I can write my expressions like exactly the way I wanted. So what I will end up with is yeah, exactly something like this. And so I think this is nice, because now once I have this, what I can do, so I can, what I did here is like I took my problem, and the first thing I did is like I wrote an internal DSL. I recognized that what I had was expressions, like I wanted to be able to write expressions. So I modeled that expression in F# without really worrying about making it pretty. What I want is I want to be able to write fully the thing I want. The thing which is awesome here too is like you're writing an internal language to represent the thing you're trying to work with, and it's going to be entirely statically checked by the compiler. So you get a DSL which is written in F#. So because it's in F#, if you write an expression which is not correct, your code will not compile. So this is pretty neat. And then once you have this, the next step would be typically you're going to use an evaluation function. So if I wanted to run dice rolls, all I would have to do would be pattern match. And I would say if you give me a roll can either be a roll of times dice, so I would do something like 4 times random something, or a value, I will give you the value, or add some rolls, and in that case I would take the rolls, sum them up together, and I would get an evaluation. So that pattern is pretty common. I ended up using this in lots of places. Like, so this is maybe a bizarre case with dice, but I've been using it in lots of real applications. Like one thing would be I gave one of my customers something like an Excel-like language so that they could change code on the fly in their own application. That's one way you would do it. Another way you could use this would be something like creating a representation for documents, and then an evaluation function would give you like a markdown representation, and another one would give you an HTML representation. So it pops up in lots of places. That was one of the biggest changes for me coming from O to the F# side, was like this idea of like creating DSLs as expressions and evaluation functions. And yeah, and then once you have your internal DSL, essentially like make it pretty, make it simpler to use, and in general the way it's going to work is like making it easier to construct. Like all I did was creating operators, and the operators really behaved as factories or as functions to instantiate things. So it's usually about instantiating things. The other thing I would say is like, you know, like every time you have a new library, a new language, like people tend to go a bit overboard and get excited with things. And so one of the common patterns also you see is like people get so excited and they create a boatload of custom operators. It looks awesome, it's great, but like it also has a cost. One of the biggest costs is like it's very hard for people to discover. Like operators, it's you don't have like dot completion with IntelliSense. So don't go crazy with custom operators. Like use them really when they make sense and they're useful. I think in this case it does, because it fits exactly the way people would write dice rolls. But don't go crazy. Everything you can do, you should not necessarily do. Like refrain from crazy operators. Cool. So, so now is like I want to move to a different piece, and I want to talk about Fable Elmish. So let's do that. And so I'm going to again talk about modeling for a second. And so we talked about attacks. Another thing which happens in combat is that creatures will move. And if they move, so the rules say on your turn, you can move a distance up to your speed and take one action. So let's look at movement. The way I would model it is probably, so this is slightly simplified, but I would have maybe 4 directions, north, west, south, east. That's a pretty straightforward case for a discriminated union. And I would model my position. A position has 2 coordinates, so that's a record, north and west. So this is my model. And now if I want to move, again, same pattern. I will use pattern matching. So if you give me a position and if you give me a direction, I will check all the 4 possible cases. If it's north, I'm going to increase north by 1. If it's west, I'm going to increase west by 1, etc., etc. Pretty straightforward, so nothing complicated. And now it's like I'm in a good place because I can start playing with my model and say like start, for instance, at position 0, 0. And I can start to say like now move north, move east, move west. So I have like this nice model, which is pretty close to the way you would talk about it. The drawback with what I showed so far is that move is only one of the things you might want to do. Is I listed that you could move during your turn and you could take an action during your turn. So you will probably do other things. So in that case, what you probably want to do is like to wrap it up into another discriminated union. I'm going to say like what you can do or the type of action you could take is you could either move or you could take an action. And I'll keep the same model. And if I do that, this is nice because now I can represent something which is more general. And I can say if you give me a state, like the state of your creature right now, if you give me a message, I'm going to update the state. So I'm going to take my message, and my message can either be a move. If it's a move, I'm going to move in a certain way. If it's an action, I'm going to do something else. So it's like now I can represent all the things I could do with a creature, I can represent within a message. If you're doing things like event sourcing, this also might look very familiar. Like this is exactly what an event sourcing model would be. What I'm describing here, my messages would be like commands, and I have like I can define like a list of commands: move north, move east. I can take now a state and I can apply all these things, which is going to give me a state, or I can pass them all at once and get the updated state. So this is pretty much like an event sourcing model, or there is a very good fit between like functional or F-sharp and event sourcing models. This is also a good fit with, in general, what an application does. If you think about what an application does in general, is like it does a couple of things, right? It's like it does something for the user, so the user can perform some operations with the application. So this is a good fit for what I called a message before. Like these are the things you can do in the application. When you do something to the application, you expect something to change. So it's like you expect something like an update function, which is going to take the state. This is what you do. This is what the state becomes afterward. And if you want to make that work, you also probably need to know what the initial state was. Otherwise, you cannot really start to apply operations. This is in essence the MVU or model view update model, which is like at the core of LMISH, which is what I'm going to show in a second. So LMISH has essentially the whole application is structured this way. Like you need 5 things. You need a model. The model is going to be this is what the state of my application. You need messages. Messages are this is what I want to do to the application. You need a function which is going to be init. So init is going to give you the initial state of the model. And then afterwards, you're going to simply have a loop. So whenever a message comes in, the message will come to the update function, which will look at the model and give you a new version of the model. Another message comes in, gives you a new model, and so on and so forth. And whenever the model is updated, you have also a function view, which looks at it and essentially updates the way this is represented. So super simple. And so now I'm going to show you that. Like so, one implementation of MVU. Jim showed earlier like Fabulous, which is one way to one area of application. I'm going to show you Fable LMISH, which is using Fable and LMISH. Like amazing. Fable is like a compiler which compiles F# to JavaScript, and LMISH is an implementation of MVU on Fable. So let me show you how that would look like. So this is where I want to go. So here I have like a very basic Fable LMISH. So first let me close this, I have like my, first is like I implemented my domain like exactly the way I described. So I have like position, direction, all of this, like nothing new. This is the model, the domain model the way I want. And my LMISH application here is going to be exactly what I said. So it's going to have a couple of elements. First, I need a model, like the state of my application. This is going to be the position, like north and west, my coordinates. Then I have a message, and my message is going to be from my domain model, like what I can do. So that was like move north, move east, and so on and so forth. I have an init function. The init function is going to give me an initial state, which is going to be a position. I have an update function, so the update function should take a model and a message and give me something back. So here I'm simply taking the message, the model, and applying the domain update, which I defined before. So right now what I'm doing is I'm just taking my domain and plugging in pop, pop, pop. I have nothing to do. The view is a bit more elaborate because that's really not domain specific. Like this is the part which is specific to your application. So my view here is using essentially a DSL representing my document. So I have a div. The div is containing, like I simply do a toString on my model because I'm lazy. And I'm also representing 4 buttons, and each of the buttons is going to show me like what operation I can perform. So I can either go north, in what case I'm going to send the message move north, west, send the message move west, and so on and so forth. And now all I have to do is I have to wire up the application here and say make a message, make an application which is with this function in it, this function update, this view, go. So let's do that. So here I'm going to view the terminal. Oh, already have it. What I want to go back here. CD fable, CD source. Now I'm going to do start. And what this happening now is actually it's starting Webpack, it's taking this, it's essentially taking my F# code, it's compiling it to JavaScript, and in a second or 2 seconds or 3 seconds, so compilation, this is good. It compiled successfully. And now what I should be able to do is the following. I should be able to go and see what my application is doing. This is a fantastic time for Firefox to do an update. So I'm going to go to localhost 8080. And here, so the I didn't promise you something nice, but at least it's working. So what I got here is like this is now like running my application locally. So what I can do is I can run go north. And if I do this, this is sending the message move north, which is updating my model, which is now updated. So I have now a fully running application, which is just working. So this is nice. The other thing which is cool is it supports also like hot reloading. So if I did something. No, it's not where I want to go. If I go back here, and I decided I wanted, for instance, to, let's say I'm going to change this to n, why not? And if I save this, it's like I'm going to see that pop, 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 it's actually rebuilding, and I'm going to see in a second pop. So it's like you can really have this extremely interactive experience where you just write your code, save, and see immediately if it's doing what you want, and keep going and going and going. So this is pretty awesome, I think. So this was like a short introduction maybe to Fable Elmesh. So now, why is it that I cared about Fable Elmesh? The reason I cared about it is because my ultimate project is the following. So when I started the first game I played with my players in the campaign, what happened is within 10 minutes, I nearly killed everybody. Which is not fun. Like I mean, it was okay for me, but like this is not exactly how you want to start playing a game. And so then I got into this this problem, which is how do I know if a fight is fair? Like I want things to be a bit difficult for players, but not too hard. Like I don't want them to die like every couple of hours. So the question is like, can I build an application which will help me figure out if a fight is fair? So what is a fair fight? A fight would be fair if players don't do anything stupid. If creatures play reasonably, then the probability of survival is reasonable. Like it's a question of probability. Like I would like to be able to say like I want to have 50% survival, 10% survival, 90% survival, something like this. To do this, the easiest way to do this would be to build a simulation. Like I could try to run the probabilities. This is insanely complicated. I could also like take a situation, run it 1,000,000 times, and see like how many cases do they die, how many cases do they survive. This is an easier way to do this. To make that work, I need 2 things. I need all the rules of the game, otherwise I cannot simulate anything. And I also need a way to simulate what the creatures do, because if I do this by hand, it's like I can decide what the goblins do, but like if my computer is going to drive the goblins to do something which is not silly, I need to have a brain or like a strategy for the goblins which is not silly. So I need to automate the decision making. In other words, it's like I want to automatically decide what the creature should do, and to do that, so that's a bit difficult because the number of things a creature can do in general is huge. And if I just let creatures do whatever, the problem I will have is like they will do things which might cause an exception, which might not be valid. So that's a bit problematic. So what I would like is I would like a model where I know actually what creatures can do. Once I have this, it's like I just have to pick one of the choices. And so that makes my problem simpler. So I kind of pulled the idea from another creature I met in my long journeys. So he's a gnome and a druid. I think druid fits Scott pretty well. So Scott Vlashin, I recommend like checking also what he does. He's like really interesting on the domain-driven stuff. And he popped an idea in a talk a couple of years back, like on a talk called Enterprise Tic-Tac-Toe, I believe, where he was talking about capability modeling, where like what you want is you want to present the user only things they can do. So this is where I pulled the idea from. And so I ended up representing druid decisions formally this way. I ended up saying, like, whenever a decision is happening in the application, I just need to know who is making the decision, what are the choices they have, so what are the alternatives, and what information they have, like what can they see, what can they not see, and so on and so forth. So I modeled this like with a type called decision needed, so with a creature, alternatives, and information. And all I had to do with this was then to extend my MVU model and add another loop here. So this is what's called the mailbox processor. So anytime the model updates, when I have a new state, I'm going to create a message which is going to contain a description of the decision which is possible. I send it to the agent here, which is going to take this, and I can plug in like arbitrary strategies, and now that thing is going to create a message which is going to back to update, and so on and so forth. So now init is going to start the model, and once this is started, is like it's going to check like creature one is on, pop, decide, message, and pop, 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 and so now I can simulate my my creatures fighting. So let me show you like how that looks. So this is what I built. So first, like let me close this. Let me close that part. So the project here, I'm not going to go in full detail into it, but like the whole code is on GitHub if you're interested in looking as to how this works. So I have like this is really 4 files. So I have one file which is my current modeling of the combat in Dungeons and Dragons. That's like, I think 1,000 lines or so not too big. I have like a part which is about data. So this is where I'm serving things like these are the weapons you have. These are the monsters you can use. I have brains. So brains is like where I have a plug where if I give you information, like I have a modeling for the decision. And finally, I have the Fable Elmish app, which I'm going to run right now. So what I want is I want to go back to view. I'm going to show you what it does. That's going to be clearer. So cd Fable, cd app, I think. npm start. So this is now going to compile my stuff. Good. And while this is happening, okay. And I'm going to do again like local host 1880. And so what you will see is like, so I didn't promise, so first I'm going to reduce this a bit. So as you can probably guess from this, is like I'm not a web developer. This is not usually what I do. So it's like this is completely ugly, or like not the nicest. But like what you see here is like modeling of a particular fight. So I decided like I would have like 3 goblins fighting. I would have like 3 wolves fighting. The wolves are here. The goblins are here. And now is like this is implementing the way the rules are supposed to work. So what I see here is that creature 0 is the first goblin, and I'm generating all the things that creature could do. So given where they are, they can move north. They can move south, all these things, and they can also have different attacks. So I can see that they're far away, but they have a short bow. So with the bow, they can actually attack the wolves. So I'm going to maybe attack this wolf here. And if I do that, I'm going to see that it executed an action, and the wolf lost a couple of points. So I can, now I'm going to finish the turn, go to the next creature, and so on and so forth. So far, I can play by hand. Like what's happening is like whenever I play, it's going to show me exactly the whole list of things the creature can do at that particular point in time. So this is the worst possible way to play D&D, right? It's like but one thing I can do also is like here I have a switch to automated, so I'm going to do that and restart. And now what I can do is like I can actually plug this into my brain, and so what you see now is like I see like exactly the same thing. Like this is what the creatures can do. So currently, like the one wolf is already dead. See also like the strategy, like the wolves are trying to charge because they cannot fight from far away. So they're trying to get closer to the creature, and yeah, like now I think they're going to.
What? Back goblin, Jesus Christ!
They're trying, but like, see, they still got destroyed. So now I run one, and I can restart, and I can do another one, and so on and so forth. And so now I'm in a good place, right? It's like with this, first I can, so this is ugly, but this is giving me a good debugger to see what I'm doing. Putting the UI together, like, it was kind of shocking for me because I don't do JavaScript or do any of these things, and it took me, like, this is not what took me time. And now I can run, like, many games and start to see if things make sense. So this is where I am so far with this project. So let me get to my conclusion. And yeah, so what's missing is like, what you saw is like a good set of the rules, not all of them. What's missing is buffs and debuffs, like all the, maybe increasing armor, decreasing armor, all these things. I haven't implemented magic yet. I'm also missing things like line of sight, terrain, hiding, all that stuff. So, but the last one should be easy. Like the buffs and debuffs, I think is going to be a bit difficult. The other thing is like right now, my decisions are not very smart. I just hard-coded them by hand. My next step will be to try to add reinforcement learning. So if you don't know what reinforcement learning is, the idea will be like, I don't know what a goblin should do. What I will do is I will have goblins play like, say, 1 million games and play a lot and see what works. So they're going to try things at random. If the thing works, do more of it. If the thing doesn't work, do less of it. So it's like the thing here is like if I do that, progressively goblins should start to learn the perfect way to fight if you're a goblin. Same for all the creatures, and if everything works fine, then I should have like an optimal strategy for all the creatures. So this is what I'm after right now. And I think I'm going to leave it at that. So I'm going to say like first like thank you, and if it's not enough, I'm going to cast bless. So I'm still Brandewinder. This is me. So a lot of the things I talked about are actually on my blog here. And if you want also the GitHub repository, Monster Vault is where my whole code is. Some of it is ugly, like it's the truth, the whole truth, nothing but the truth. And yeah, so this is what I had. Like, thank you very much.
Are you about tomorrow for conference?